All right. Hi, guys. Good morning. So today we are doing recursive function rules, right? And remember, function rules mean an equation on geometric sequences. So I put this up here. In most geometric sequences, a recursive formula is easier to create because you're just looking at whatever the common ratio is or the common difference. And so it's easier to create, and it's sometimes simpler to even look at and know what's going on, right? Like, for example, in this one, I'm just saying, hey, any term is equal to 2 times the previous term. All right. So it's easier to say. The downside of it, though, is that you can't just plug in any value for n. You can't say, oh, n is 100, right? I want to find the 100th term, and so now I can find the value for the output or the y. All right. So it does have a value in its simplicity, and I actually looked it up, and it is with like computer coding. They use recursive functions a lot, right? Where they're just trying to find the next thing, the next term in the sequence. All right. So that's a little bit of why we're using recursive. Again, here, this is in subscript and this is in function notation. So we've got two different notations telling us exactly the same thing, right? So this little one and this one in the parentheses means the first term is 3. And then here, the only difference is I've got this n lower, right, for subscript, and in a parentheses here. Again, they mean the same thing. These are both different ways of writing the y value, all right? Equals 2 times the previous term. N minus 1 tells you that's the term before it, the previous term. Okay, so really work on those notations and just understanding what they mean. And let's do a couple examples here. Okay, so a recursively defined sequence is shown below. So this right here, this little one tells you the first term is 5. So if I were writing these as a sequence, right, just a list of numbers, I would put 5 first. All right, so now this n plus 1, and you might have to review yesterday's work, tells you that this is the next term, okay? So the next term is equal to 2 times whatever term you're on now minus 7. Okay, so right now I'm on term 1, I'm on 5. All right, so 5 times 2 is 10, minus 7, 3. Okay, so that would give me 3 for my next term. Okay, now I'm just going to keep doing that sequence. So now I'm on term 2, right? So 2 times 3 is 6, minus 7 gives me a negative 1. So I'm just following this same pattern. 2 times whatever number I'm on now, minus 7 will give me my next term. All right, so I want to know a sub 4, that means my 4th term. So I have 1, 2, 3. I need the next one. All right, so now I'm on negative 1. 2 times negative 1 is negative 2. Minus 7 is negative 9. Okay, so let me just double check. 2 times negative 1 is negative 2, minus 7. Yep, okay. I would check all of these on your calculator. So this is what they're asking for. So the 4th term, 1, 2, 3, 4, is negative 9. Okay, and that's my answer using this recursive function rule right here. All right, so we're going to go on to the next one. I'm going to show it to you, and then I'll erase, because you guys know it takes me forever to erase. And you guys can ignore that. Okay, so while I erase, look at this, try to figure out what we are supposed to do, and even feel free to pause and try it yourself. Okay. All right. So you have a sequence, and I think my face is covering what the rest of the directions are. So let me move down here. All right. Find a recursive formula, right? So sometimes it's called a function rule, sometimes it's called a formula, other times they just say equation, right? So here's the sequence. So the first term is 3, which is why here the first term goes up to what would be about 3. Okay, the second term is 6, so it goes up to 6, right? So this graph right here represents the sequence. The first number would always be where x is 1. The second number is always where x is 2, right? And in this particular function, they call the x term n and the y term f of n, right? Okay, so I'm just going to make a table actually. So we have x and y, but they don't use that. Instead of x, they're using n, and instead of y, they're using f of n. Do you guys know what notation they're using when they say f of n? Okay, you should say function notation, all right? Okay, so my first term is 3. My second term is 6. And remember, these are just the coordinate points here also. So it's represented in both ways. So just because you don't have an x value, you know the x value is just first term, second term, third term. Okay, third term is 12. So what is happening here? Like, what is the common ratio in this geometric sequence? All right, so think about it. All right, and I'm not sure. I'm looking, I see it's going up, right? So that kind of tells me growth, but I'm not sure about the common ratio. So I'm going to find the common ratio by saying, okay, the common ratio, I know I can take any of these terms. So let me just choose 48 just because, and divide it by the previous term. And its previous term is 24. Okay, so I could have chosen 96 and divided it by 48. I could have chosen 12 and divided it by 6. Okay, so 48 divided by 24 is 2. So now I know I can do times 2 every time, right? 6 times 2 is 12. And I could do that for all of them. And in fact, I think I will. Okay, so times 2. That's why it's called the common ratio, because I do this every single time. All right, so I want a recursive formula. So remember, recursive formulas are simplified. So I know I'm going to have 2 times something, okay? And I'm going to keep it in function notation. So let me just say whatever term I'm on now, right? So let's say I'm on 12, okay? So 12 would be equal to the previous number times 2. Now, how do I write previous number here? Okay, so the previous number would be n minus 1. Okay, so go back, look at your notes. This is your recursive formula, your recursive function, and I can use this for any of them, right? So if this is my now, and this is my previous, and remember, previous is the one that comes before previous, okay? Then that means that any number I'm on, so let's say 48, is equal to 2 times the number that comes right before it, 24, right? So 2 times 24 is 48. Okay, so that is all for today. Good luck with your Desmos, and I will see you at a future date.